Alrighty, so I'm not going to spend a lot of time on it. This is a fairly basic concept. So electrical current literally is how much charge passes a point in a particular amount of time. Okay, so for example, if you have a current of 4 amps, right, that literally means 4 coulombs of charge pass by every second, right? And so, you know, if 12 amps or 12 coulombs goes by in 3 seconds, that could be 4 coulombs per second or 4 amps. Okay, so that's a pretty basic concept. So literally, it's just like water current, which might be like kilograms per second of water, right? Only this is coulombs of charge per second. Okay, just 2 points I want to make, and the first point is that it's not hard to have a current of 4 amps. You have, like, you know, the heater that heats up the back window in your car is, you know, 10 amps or 50 amps or something like that. And that literally, you know, 10 amp current is 10 coulombs a second. And I think in the last chapter we realized that, you know, a coulomb is just a huge amount of charge. The reason that we can have 4 amps, though, go hucking by in a second on a, you know, fairly modest wire is that there's a lot of atoms in the wire. Okay, and so even though a coulomb is something like 6 times 10 to the 18th particles, right, or the charges, electron charges, okay, just think of that wire. Basically, these coulombs, you've got all these positive charges in the wire, and those electrons are very close to those positive charges. We haven't split them up very far. They're just shuffling along the wire, and there's a lot of them. Okay, and that's why, you know, 4 coulombs per second going by is no big deal. The second thing I would like to point out is that a coulomb is not a base unit. Actually, a coulomb is defined as an ampere flowing for 1 second. Okay, and an ampere is defined in terms of force and distance. Right, the ampere is the current flowing in each of 2 long, straight, and parallel wires exactly 1 meter apart, such that there's a force of attraction or repulsion of exactly 2 times 10 to the minus 7th newtons per meter of length. Okay, so an ampere is defined in terms of newtons and meters, right? And a coulomb is defined as an ampere flowing for a time of exactly 1 second. Okay. Anyway, let's get to our example problem here. So let's hit the right arrow, make that a pen. So what charge passes a certain point of a current of 250 milliamps flows for 12 minutes? So this is about as hard as you can make this, right? If you solve this for Q, right? Q is I times T, right? So if you're looking for the formula for charge, I have it. Do you get it? There it is. Okay, anyway. So current times time, right? So the current, milliamps, is a fairly common unit of current. A milliamp is 10 to the minus 3rd amps. So 250 milliamps is 0.250 amps, or 0.250 coulombs per second, right? 12 minutes is a lot of seconds. Let's figure that out. That's 12 times 60, right? So 12 times 60, I want to say 720, but yeah, it is 720 seconds. Now we're good to go, right? Okay, so the charge that passes is the current. So 0.250 coulombs per second times 720 seconds. And that's 180 coulombs. Right? And that's a modest current. Okay. Anyway, there you go. Try those whiteboards. See if you can do them. You probably don't need to watch the video. Good luck.